Hi everybody. Good morning or good afternoon, good evening. This is Ira Goldstein, Director for Product Management with responsibility for the Design Explorer. And then joining me, as Pratish mentioned, is Atul Miskin, Senior Manager for Vibration and Acoustic Solution. And Atul is going to help with a portion of today's presentation and demonstration. So let me switch. Here we go. So I have a very pretty basic agenda for what I'd like to cover in today's session. I want to talk a little bit. So one thing I'm going to do is maybe a little bit different than some of the Design Explorer presentations in the past. Typically we focused on Design Explorer inside of HyperWorks. So the Design Explorer workflow that hopefully most, maybe all of you are hopefully at least somewhat familiar with. But what I want to do today, so this being a point release, we have a modest set of enhancements, but I think still some exciting things that I want to share with you. But besides that, over the past release or so, a lot of work has been done to modularize or make the Design Explorer workflow common so that it can be exposed and used in applications other than just HyperWorks. So I want to kind of take some time today to talk a little bit about that. So the first thing I will talk about is for 2022, Design Explorer was released in Inspire. Using this common module that I mentioned. Now, Mark McDowell did do a GTA a webinar in the 2022 timeframe introducing Design Explorer there, and I think there's probably a lot of overlap between that audience and this one, but I still thought I would take a little bit of time and kind of reintroduce that as maybe not everyone is aware, and it would also help me allow me to talk a bit about the common module. So I'll cover that briefly, and then the remainder, so that's number one. Number two, I will talk about some enhancements to that very same Design Explorer workflow in Inspire that are enhanced within 2022.1. Then Atul will come in for item 3 and talk about some NVHD enhancements to using Design Explorer that I think he may have covered in his NVHD specific webinar as part of a larger presentation, but I've asked if he wouldn't mind sort of reiterating that for this group. Again, it helps to, I think, see the breadth of Design Explorer and how it's starting to sort of branch out and be used and exposed in many more places. And then finally, last but certainly not least, Design Explorer enhancements for 2022.1 within the good old HyperWorks Design Explorer itself. And I think in each of these numbers 2, 3, and 4, at least 2 and 4, I will do live demonstrations to try and hit on some of the highlights in terms of enhancements. Number 3, Atul will cover, and I believe he plans to do a live demonstration as well. So without further ado, let me jump in and talk about a little bit of the background of Design Explorer and Inspire. And no sooner having said Design Explorer and Inspire than I show a picture of Design Explorer and HyperWorks. But the point of this slide, so this just shows many of the attributes or features of the Design Explorer workflow that, again, hopefully my purpose here is not to go back and reintroduce Design Explorer. Again, hopefully everyone is well familiar with that. But the point of this slide is really just for me to mention that historically, up until 2022, Design Explorer in HyperWorks was designed, architected, exposed within HyperWorks itself. It was tightly integrated to HyperWorks in terms of the architecture, using HyperWorks entities, HyperWorks database, and so on and so forth. And I just wanted to kind of mention that and use this slide to illustrate that point. As I mentioned already, in 2022, Design Explorer was exposed in Inspire. So this slide looks very, very much similar to the previous HyperWorks slide. And again, the point is just that we are now exposing Design Explorer inside of Inspire, and we're starting to build up a very similar workflow with lots of the same kinds of features and tools and workflow. But again, the point is not necessarily to point out each and every feature in this case. This is 2022 material, and this webinar is focused on 2022.1. So this is just a quick, I wanted to, again, I'll take a little bit of time, not too long, just to introduce, as Mark already covered this, but for those who aren't familiar, so this is just a look at some of the aspects of Design Explorer exposed inside of Inspire. And for those who have seen it, maybe it's a little bit of a repeat. If you haven't seen it, but you're familiar with Design Explorer and HyperWorks, I think you can kind of recognize a lot of the same characteristics here. We have a workflow ribbon inside of Inspire for the Design Explorer workflow, and there are, as in HyperWorks, there are tools for creating and managing explorations, for setting up the components of your explorations, design variables, responses, and goals, and then for evaluating, running, and post-processing your explorations. So again, very analogous to HyperWorks. There are tools for defining your inputs or design variables. And one of the really nice benefits of Inspire is all of the design variables are geometry based. Inspire has a lot of great tools like the Sketcher as shown here for parameterizing your model. So a lot of the work that Design Explorer requires is really kind of done up front, and we just kind of get for free, so to speak. So if you parameterize your model, and you'll see this in a demonstration, then we can kind of just take all that information and use it really directly as design variables. So it's very seamless and easy to use. Responses, so similar to HyperWorks, very graphics driven. We can support mass, volume, displacement, stress. Responses, new for 2022.1 is a frequency response as well. I'll demonstrate that. And it's all, again, very interactive, geometry based. You just click on your model. I want to have the displacement here or the stress of this part, and so on. And then evaluate. Very similar to HyperWorks, we can submit explorations and monitor their status, and then and view results. Again, one thing to note here: Inspire, of course, supports OptiStruct, but also SimSolid as solvers. Design Explorer can leverage that, and I think that's a big differentiator too. I mean, it's just the speed at which SimSolid, I'm sure everyone knows, is able to solve simulations really facilitates exploration, because if you want to run designs of experiment or optimizations with large numbers of runs, you know, SimSolid solving so fast, you can do in just a few minutes what may take, you know, hours or more in a classic FE solver. And then the last point, Results Explorer, which is a tool also in HyperWorks Design Explorer, where we just have all of our post-processing tools. So things like summary tables, loading and comparing run results and contours and animations, linear effects, trade-offs, and scatter plots. And I'll kind of touch on some of this in a demonstration. So now finally so all that was available in 2022 as a first release. We've continued making some incremental enhancements to that. This is, as I say, we have some modest enhancements, but I think continuing to move in the right direction. You can do things like duplicate explorations and responses. I'll show this in the demonstration. It can be kind of handy when you're creating a lot of responses and you don't want to have to create them one at a time. You can make duplications, or if you've created maybe one DOE and you don't want to have to create another DOE or an optimization from scratch, you can duplicate the first one and have a lot of reuse. So it just kind of helps make things a lot easier and more efficient. Model update or apply variables. I'll demonstrate this as well. When you're viewing your results, you can view and load results from one run or another and look at the contour or animations. We now have a feature that will allow you to update the existing model based on on a particular run. So for example, maybe you've run an optimization and you viewed the results, but now you want to actually apply all the variables from that optimization directly into your model to actually save off or have a copy of your optimal model. So you can do that. I mentioned a bit earlier frequency response, so one more response type for doing some different types of analyses or simulations. And then a nice little tool that I'll demonstrate, where we have kind of I would say a lot of enhancements that we'd like to do for this tool, but I think it got to a point in 2022.1 where it's already pretty useful. So we decided to expose it. I'll show you what that means, but it's with the parameterization of models in Inspire, if one isn't careful, you can end up defining design variables where maybe when variables are applied for one run or another, you can end up with some potentially with some issues to your geometry. You can create gaps inadvertently or some part overlaps as geometry moves around. And this is just a tool that helps you to kind of check to catch some of that up front. So with all that said, let me jump into a demonstration. Just it's a pretty simple demo, but I think it'll show the workflow, and it'll also allow me to highlight some of the various enhancements for 2022.1. And I always like to show a little picture beforehand and describe what the demo is. Um, I'm not, quite frankly, it's not, maybe some of these demos aren't super realistic, but I think seeing some of the context or where even if it's just a component level or a rib component level example like this, I sometimes think seeing the image in context at least, makes it a little more meaningful. So this is a model that Mark McDowell provided me, portion of a fuselage, and the rib in blue there is the component of interest. The setup that we're going to do kind of reflects this slide a little bit. Just kind of a quick overview. The design spaces, there's a number of design variables that have been defined on the rib itself, and you can kind of see them in the sketch, and I'll show this in Inspire in just a moment. But as I mentioned, if you've parameterized your sketch, as this one has been parameterized, everywhere you see this f of x or function is a parameter has been defined, or a variable has been defined, and we can leverage it. So just for example, the length here from the datum line here out to rib 1, this vertical rib is parameterized. It's got a nominal value of 50.8 millimeters, and as that changes, this rib effectively slides back and forth, and rib 2 and 3 and so on, and then the diameters have been parameterized. So we've got a design space that looks like that, and then we're going to define just quickly 2 or 3 responses here. Because frequency response is an enhancement for 2022.1, I decided let's use some frequency responses in this example. So we're just going to do a normal modes analysis. We're going to look at the mass, maybe we'll attempt to minimize it, and we'll look at the first couple structural modes at their frequencies, and then maybe assign some goals that we can then use for an optimization. So let me jump out of the presentation for a moment and into Inspire, into a demonstration here. So here's that rib model that we mentioned. Just to kind of show a quick background here, if I double click on the sketch, you can see a portion of the sketch here where the sketch has been parameterized. I showed that in the slide already. But if we look at the variable manager, again, we can see, there we go. Look at the variable manager, so we can see again, rib 2 is this vertical rib here with a value of 203.2 millimeters. If we just make that, say, 250, you can see that the rib moves over. So that's just all basic Inspire parameterization stuff. Nothing to do with Design Explorer yet, but just showing that if the model is set up and parameterized in this way, now the Design Explorer workflow becomes pretty quick and easy. So I'm going to jump to the Design Explorer ribbon. You can see the ribbon here with the different tools. Let's also go to View and turn on Design Explorer browser. Switch to that tab. And this is not a necessary step, but I like to have it here. Just it helps us to follow along and see as entities are created or used within the process. And right now you can see there are no explorations or anything created, but however, the variables that exist in the model are automatically sort of assigned as design variables already for us to use. They're not active, we're not using them yet, but they're here by virtue of the model being parameterized. So let's go ahead and just kind of step through. If I click on any of the tools in the ribbon here, I get this Design Explorer browser with the various tabs, and each of these tabs corresponds to one of the tools in the ribbon. So you can use the ribbon to activate the dialog at any of the given tabs, or you can just kind of use the dialog itself as sort of like a wizard to step through as you're creating your exploration and entities. So we'll create an exploration. We'll just create an optimization. You can see in the browser an optimization has been created, and here it is in the dialog as well. I can select on. Sorry, let me make sure I have not. Oh, yeah, no problem. It was just warning me. I had previously run an exploration in this folder, so it was warning me that it was already there, and I would overwrite it, but I don't mind. So you can pick here which design variables you might want to use in your exploration, or you can select all and so on. You can switch tabs and look at the design variables in more detail. So here you can see the nominal value is retrieved from the variable itself, and then we automatically assign um, default minimum and maximum, or lower bound and upper bound values at plus or minus. I think that's 10% of the nominal value. But as I mentioned earlier, one of the issues that may arise is as these variables are used within the exploration, you know, potentially issues may arise if you open gaps in your geometry or have some overlaps. So this min max check tool has been added. As I said, we want to refine this. We want to make this more automated. But for now, again, I think it already brings value. And the way it works is based on your selected design variables. If you click on min max check, it'll open a table. It's basically creating a full factorial DOE table in the background. So it's basically perturbing each of the variables in all the permutations of their min and max values. And then if you want to check any of them, so for example, here's rib2 at its minimum value. Let's see, this one looks interesting. Rib2 at its minimum value, and the diameter 2, which is this middle hole, at its maximum value. If we check that, the model will be refreshed, and we can see that the rib has moved probably further than we want it to move, also in combination with the diameter being increased. So this is probably something we would want to check and to maybe change the minimum value of this rib. Similarly, if we look at one that I think will also not be so nice, when rib sorry, that's rib 3. When rib 3 is at its maximum value, we notice that it also moves further. We probably just want it moving within this space here between the two holes. So that's the kind of information we can glean from the min max check tool. And then we can go to rib 3 and we can make some corrections. You know, we would have to interrogate the model more, but we might know that 325 is the minimum value, and maybe like something like 410 is the maximum value. And then we could redo the check and see that this rib is then moving. I'll just do it real quick. So at 325, for example, now it moves just to the edge of that hole. And at 410, we'll just check one of them. We don't have to check them all. We can see that it now no longer moves past the space where we'd like it to be. So again, I think that's a pretty handy tool. Let's go ahead and we'll just check all the rest of the design variables that we want to use to set up our optimization. And let's create some responses. And we can just click on the plus here. Maybe we want to define, let's say, a response of the mass of the whole model. So we'll just click the play button there, and we get a mass response created with this this call out is put at I think it's the center of mass of the component here. So this is created as a response. Maybe we know that we're going to use this in our optimization as a goal, as an objective. We can do that using the goals tab, or we can just directly here on this this micro dialog switch that to objective, and minimize is fine, and we can see the objective was created. We'll create a frequency response. Very similarly, this is just created on the model itself. And similarly, maybe we want to make this a constraint. So we'll constrain that to be greater than 56 hertz. And we can do the same thing for frequency 2, but just because one of the enhancements here was the duplication of responses and explorations, we can also just click on the frequency 1, duplicate it, create frequency 2. Let's make that active so it'll be used in this exploration, and change that mode number to 2. And then we can similarly create a goal for that to be constrained greater than some value of interest. So that's really all there is to the setup. When it's time to evaluate or to run the exploration, we come to evaluate here. This looks very similar for those who are familiar to the HyperWorks evaluate dialog. We can change the options. We can view some different options here. For example, just to note, run options, we automatically know because we have frequency responses created that we want to run normal modes, and we choose the number of modes appropriately based on how many structural modes have been selected. And then when we're ready, we can go ahead and run and evaluate the exploration. So this does run really fast in SimSolid, but I've got one here that I had previously run, so I can just quickly show the results here. In fact, I ran a DOE and an optimization previously, and when we're done, we can click on the Results Explorer. And not to sound like a broken record, but for those familiar with HyperWorks Design Explorer, this is very, very similar. I get a summary table. In this case, it's an optimization. The DOE summary table looks similar. Optimization is color coded, showing information from the optimization itself. I guess last thing I want to show is we can load results for any of the given runs. Let's pick the optimal run and load the results so we can get a contour. We can look at animations. There's my first that's displacement, but I think the first frequency is the first mode is very similar. This mode and then the second mode looks like that, and we can see that our constraints have been satisfied, greater than 56 hertz and greater than 100 and whatever that was, 140 hertz. And we have our optimal values here for the different rib settings. In fact, when we load the results, you can see they're loaded. Both of these ribs have moved to the center. I think this angle has changed slightly, and some of these diameters have changed to help minimize the mass. Last feature that I wanted to demonstrate as an update is the apply variables. So as the results are loaded, you can see that you can see what the model looks like for that run. But once I jump out, then the model reverts back to its nominal state. If I wanted to save that model or to have the model in its optimal state, in this case, I can apply variables, and then we can see. Oh, looks like there's an issue with those callouts there, but you can see the model is set to its optimal state, and then I have the optimal model that I can then save off. So I think that's kind of all I wanted to cover in terms of Inspire. So in quick summary, Inspire Design Explorer was added to Inspire for 2022. We talked a little bit about that, and then some of the enhancements, frequency response, the min-max checker, and the load model and duplication, I think were all covered in that demonstration. So hopefully that gave you either a good introduction to the workflow, or if you're already somewhat familiar, you got to see some of the enhancements. So with that, let me turn it over to Atul for the next item on the agenda, which is the Design Explorer in NVHD.
Thanks, Ira. I'm going to share my screen. Let me know once you start seeing it. Are you able to see my screen?
I can see it, yep.
Okay, fine, thanks. So one of the features missing from NVHD was the optimization workflow. Today, what I'm going to talk and show is the optimization workflow introduced in NVHD using Design Explorer infrastructure. The idea is to show the flexibility, the adaptability of Design Explorer framework inside NVHD, which can be extended to other products for the relevant workflows. So as far as NVH optimization is concerned, so the users has two main interests. One of the interests is to reduce the NVH responses for the FRF responses for achieving the targets, and it can happen at full vehicle level or at subsystem level. The second interest is to change the modal frequencies, like the local mode frequencies, global mode frequencies, to achieve the targets, and this can also happen at subsystem level and component levels. So today, so in this slide just shows the overall workflow for setting up the optimization problem at a full vehicle level. The first step is to select or define a load case, and then to select the responses for which needs to get optimized, select the design variables which needs to get changed or optimized to achieve the responses, define the objectives, define the constraints, and then submit the optimization run. So these are the main steps for setting up the optimization run at full vehicle level. And this optimization workflow is very important, and it can happen at various different phases in the product development cycle. So for example, sometimes or at the beginning during the design phase, users are interested in introducing only the responses. Users may be interested in introducing the response and to maintain the mass or maintain the mass and reduce the mass and maintain overall vehicle response performance. So in summary, this optimization workflow is being used by the users throughout the vehicle development process. So it's very necessary to have a seamless workflow, a user-friendly workflow, so that the optimizations can be set up pretty quickly. So inside NVHD, the way we have used Design Explorer is it is used for defining the design variables, responses, objectives, and constraints. So to start with, defining or selecting a load case happens inside NVHD using Analysis Manager. Then to define the variables, responses, objectives, and constraints. For this, we have completely used a Design Explorer framework. And the most important thing is we have enhanced the Design Explorer so that we can write out the OptiStruct solver deck for this complete optimization setup. So all the parameters which get created inside Design Explorer, they get converted to OptiStruct solver cards, and that is how we write out the OptiStruct solver deck, submit the optimization run. So generating the OptiStruct solver deck and submitting it for OptiStruct run is done through NVHD. And then we have a dedicated post-processing utility inside NVHD. So, but we are going to focus today on the pre-processing side. So let me, this slide talks about the coupling between NVHD and Design Explorer. So the most important thing is we have the APIs to convert the parameter entities into OptiStruct solving cards. So what we do is we define the variables, responses, objectives, and constraints using Design Explorer. Once they are selected, then the parameter entities are created. These parameter entities are then converted into OptiStruct solver decks using the APIs from the Design Explorer team. These OptiStruct solver cards are given to NVHD Analysis Manager, and finally we write out the OptiStruct solver deck. So this is how the NVHD and Design Explorer functionalities are integrated seamlessly. So in general, this optimization workflow is integrated inside Analysis Manager for problem setup for optimization as well as results post-processing. So you can generate the solver deck for optimization from here and also do the post-processing. So let me show you a quick demo of the overall process. So here you can see that I'm in the NVHD profile. This is just a simple front suspension tutorial which is loaded. I'm going to Analysis Manager, which is nothing but a place to generate the load cases. So here you can have different load cases. So I'm going to select the engine idle load case. And I'm going to set the model representation. So this is defined. The next thing is to define and apply the analysis setup. So what is going to happen is at this point of time, we are going to generate all the load cases which are necessary to get defined for the optimization setup. Once the analysis is applied, this newly introduced optimization checkbox is activated. The user can click this optimization checkbox, and from here, he can go ahead and start defining his optimization setup. And from at this point onwards, it's all Design Explorer. So here, the first step is to define design variables. I can add design variables, so it opens a guide bar, and the users can select materials, properties, connectors, or modal parameters to get defined as design variables. Here, connectors and modal parameters, these are some enhancements from the Design Explorer team, so that these are specific to NVHD profile here. These connectors are nothing but NVH connections, so user can come and pick these connections from the graphics area. And users can select the attributes. Even this is the enhancement for us. And user can create these connections as design variables. User can also select modal parameters to get selected as design variable. This is again enhancement for us. User can select properties. He can click it from the screen, specify the attributes. change the range of variation. Maybe let's go from 15%, minus 15% to plus 20%. Created. So these are all the design variables, let's say, I have selected. The next step is to select the design responses. So these design responses are automatically populated coming from the responses for the load case setup from the analysis manager. So this is one way of creating design responses. If user wants to add any additional responses, then user can click on this, and then we again open this guide bar where user can select the response type, select the nodes, and go through the complete process. So right now what I'm going to do is I'm going to just select some of the design responses. So let's say I'm going to work on 3 responses here. I can select the type. There are different requests you can select from here. So you can select, let's say I want to track RMS response for this response. Then I can think like I want to do summation for this. I want to do mean for this. And I can also specify in what frequency range I want to do this. So let's say specify here 50 to 80. I'm just selecting them arbitrarily now, but selecting this minimum and maximum frequency really depends on the response. And then I can select the load case from here, for which load case I want to define these responses, and that's it. So now my response definition is complete, and I can go and select the next step. And here I can create a derived response, which is where a user can select 2 responses, and he can create a relationship between them. So in this case, I want to create a relationship between the responses in X and Y direction and create a derived response out of it. And I can say create. And the function can be, maybe you want to have an average relationship between these 2 responses. And the next step is to define the constraints. I can go and add a new constraint. So I can select a derived response here or any other response. And what you see next is to specify the bounds for the constraints. I can specify the bounds by specifying some absolute values, or user can also define it in terms of curves. You can define the curves also. So I have defined the constraint. The next step is to define the objective. I can go and select the response to get defined as objective. And my objective can be minimize, it can be maximize, it can be minimize the maximum response or maximize the minimum response. But in this case, I'm going to, my objective is to minimize the response. And that's it. So now what I'm going to do is click define. I will, my optimization setup is created, and I'm going to hit optimize here. And I can write out a solver deck, or I can also create a job for it. So let me export out the solver deck. And this is ready to solve solver deck using OptiStruct. I can open the solver deck and see that all the cards are related to, this is for objective. All my design variables are written out here. All my responses are written out here. All my constraints are written out here. So users can just take this and submit it for optimization. So this is the way we have used Design Explorer features and introduced optimization workflow inside InVHD. Thanks a lot to Ira and team, and Amar also, for helping us in introducing this workflow inside InVHD. And this is just a starting. And there are many more enhancements planned to make this workflow better and better. So that's all from my side. Ira, you can continue.
Thanks, Atul, and thank you for the great presentation and demonstration. I think it's just really awesome to see Design Explorer being useful and applied in other areas like MVHD. So yeah, that was really great. And I think what what I like about it is it's a domain that I'm not so well versed in, but you've been able to take Design Explorer and expose the aspects of it in the same kind of user experience, which I hope is helpful for your users. And then, as you mentioned, I think another neat thing is the Design Explorer is being used in a slightly different way, whereas in the standard workflow, we're of course leveraging HyperStudy, but the team that you mentioned, Amarendra and team, have created an API where for this specific workflow, I believe it calls OptiStruct directly, and as opposed to HyperStudy. So it's pretty flexible in that way, but the same user experience and UI can be used in both cases. So it's kind of a real common sort of experience, which I think is good too. Let me reshare my screen. And then I have one more topic to cover. The last topic in the presentation is Design Explorer enhancements for HyperWorks Design Explorer. And as I mentioned, same kind of theme here. It's a modest list, but it is a point release. And but I do think, in particular, I'm going to try and close on a big heavy hitter with the field prediction enhancement. So I think and hope I think it's really exciting what's been enhanced here. But I'll get to that, and I want to close with that. But just first, a couple, one relatively small enhancement, one point here about Abacus, and then finally field prediction. So this is it's a really fairly small enhancement in terms of enhancements, but I think it's one that we actually got a lot of feedback from users, both internal and external, regarding this multi-step. So on the left-hand side, 2022, when you want to go evaluate an exploration, DOE or an optimization, it was a multi-step, multi-click kind of process. You would export all the files and all the information in the first step, and then you would run it in the second step, and then do your post-processing. So people were confused, if not a little bit annoyed by needing to do the extra clicks, and they didn't understand why we were forcing them to do it. So for 2022.1, you can now run in one step. Once you are set up your exploration and you go to the evaluate dialog, you can just click run, and you're done. So a small enhancement, but since a lot of people had kind of noted or in fact complained about that, we wanted to fix it, and then I wanted to just let everyone know that it's done. Next, Abacus support. Abacus support was there prior to this release, but it was behind an environment variable, pending some additional work and additional testing before we were really confident in that solver support. So we actually wanted to expose it for 2022, but due to other technical reasons, it remained behind the environment variable. So again, this is more just a note for everyone that Abacus is now, if you switch to Abacus solver interface, you will see Design Explorer. The ribbon will be there, and you can use it, and it should work as well, similarly, and as well as OptiStruct Radios and also LS-DYNA, which had previously been exposed. So if there are Abacus users, Abacus customers, I would encourage you to sort of take a look and promote this. We could use any and all feedback to ensure that we're supporting the necessary design variables, responses, and the workflow itself. So encourage you to take a look and let us know what you find, so that we can make sure that we're doing things well, on the right track, and we continue to expose and enhance things as needed. The bottom portion of this slide is really just a reminder that we support very easily and seamlessly OptiStruct and Radios out of the box using the locally installed solvers with the installation. But to use Abacus and LS-DYNA, or even non-locally installed OptiStruct and Radios, I just want to remind everyone that the register solver script feature is there. That's a look at it on the bottom, so you can register solver scripts. It's very similar to what you would do for those who might be aware of HyperStudy in the same kind of scenario to register solver scripts. So it's kind of a similar workflow if you're familiar with that, but you can register your custom solver scripts to point to Abacus or any of the other solvers. Okay, so finally, this is a last enhancement is the field prediction enhancements, and just a real a shout out and a special thanks to the EDS team, in particular Jonathan Aller and Joe Paget, and I'm sure others. So forgive me if I am forgetting people, but they provide the great ML AI technology across the board, and then of course that which we leverage in Design Explorer. Particular thanks for that. And there's a lot of also, I think there's a lot of high level messaging. I think even Jim Scapa mentioned it in recent Wall Street presentation that he gave on the convergence of artificial intelligence and simulation. Uh, and I think Design Explorer is just really uniquely positioned, although there's a lot of AI being exposed in many of Altair's tools now. I think Design Explorer is uniquely positioned because, you know, part of Design Explorer, fundamentally is generating simulation data in the form of designs of experiments. So this data just naturally lends itself to being trained by various machine learning models, such as field prediction and others. And we're continuing to add additional features that we either have currently or that we have in our roadmap. But for 2022.1, we have enhanced the field prediction, I think, fairly significantly. For those who, I should have put a picture of 2022 here, but for those who may already be familiar, field prediction allows us to view results in terms of in the form of contours or deformed shapes or animations on the entire model across the field of the model in virtually in real time. And I'll describe that a little bit, and I'll show a quick demo here and then wrap up. Prior to this release, the functionality was limited to displacements. So we could show displacements and deform shapes. And, I think it was a great feature, but it was limited in that way. So let's look at what we've done for 2022.1. The field prediction is exposed in the trade-off panel, and you can see where that is here in Results Explorer. It's the third tool over, highlighted in purple. And just a quick summary for those, again, who may not be familiar or not have seen or used this panel. At the top there, we have our design variable sliders, and you move those around, or you can even key in values in the value column directly if you wish. But you can move these sliders around, and effectively that changes the value of a given design variable. In this case, it's all thicknesses, but it's not limited to that. And when you've done that, you get a couple of pieces of information. First, we have formerly this was labeled responses. Now we've renamed it to fit prediction. I think actually a more appropriate name might be scalar prediction. So we may make that change going forward. It's collapsed here because it's not part of field prediction, and I didn't really want to talk about it. But these are predicted values. They're scalar values for your responses that are defined in your exploration, and they're based on a response surface fit that we get from HyperStudy, having run a DOE. But these are scalar, so they'll tell you my displacement for the design variable settings that are currently set there. For these values, I predict the displacement at node 10 is 15. I predict the stress on this property is the max stress is 180 megapascals, and so on. But it's a scalar prediction. In contrast, the field prediction, as I mentioned, is a prediction across the entire model. So you get a fully contoured model previously with your displacement results, but now in 2022.1, we can get a prediction for virtually any result type in the simulation. So this example here shows displacement, stress, and strain, but it's not limited to that. Just a few more details about what's here. You can request to have the report generated when you submit the DOE. There's a box on the evaluate dialog where you can check the box and say, please generate this field prediction report. You can also generate it on the fly once you've run your DOE using this button here. But it may take several seconds to a minute or two, depending on the size and complexity of the model. So if it might be convenient just to request it up front. The predict button, so you'll select which result type you would like to see predicted, like stresses, and then click on predict. and it'll show the prediction. And then the verify button is there if you would like to verify the prediction or generate a one-run solver job based on the current settings. So you may have the settings set as shown here. You click predict, you see your stresses, and you think, okay, that's an interesting one. I want to verify that. Click the verify button. It'll export and evaluate one single solver job with the current state of the design variables. And then finally, I already mentioned the result types are here. So this is kind of newly added for 2022.1. Previously, there was like just nothing here because we only did displacement. So you clicked predict, and we would predict the displacement results and show you the contour. But now we've enhanced this GUI to show you all the different result types that are available, and then you can train. By default, we'll train displacements as in the past when you generate the report, but you can train additional results as needed on demand. Okay, so let's do a quick demo of that. This is the last thing I have to share this morning. Again, just a little image. We have a larger wing model that I use for a lot of demos. To just do something very quick here to demo in real time, I've just kind of doctored this up. I've grabbed the first rib there from the airplane wing and isolated that and just applied some loads to that to get some results to demonstrate. So the setup is, I mean, this is just all sort of standard Design Explorer. I'll just quickly, I'm going to run through it just because it really only takes a second or two. So we can create a DOE. We'll accept a default location. We'll create a bunch of gauge variables or thickness variables. We'll just select everything and create. We can create responses that as we wish, maybe a mass response. Maybe we're interested in displacement at a certain point, and maybe we want the stress in, let's say, just these. Well, I'll pick them all these components. So there, and we can continue on and build it up. But everyone hopefully should know how quick and easy Design Explorer is to use. So we've just created a DOE in about 10 seconds. We can go to evaluate it. Just to show quickly, the generate reports option is here. Field prediction, if we want to generate the field prediction report, we can do field prediction and or clustering. In this case, we'll do field prediction, and then we can use the single click run to run the DOE. And it's just that simple. The results of that I have here. So this is a very similar DOE that I previously run with the same inputs, mass, stress, and strain, in this case, response. Let's open Results Explorer, and we can see the usual results, summary table, linear effects, and so on. I'm going to jump right to the trade-off panel. So just as you saw in the slide, I will collapse the fit prediction because we're not interested in looking at that right now, and we can see our field prediction portion down here. So the very last thing to show, really what was depicted in the slide is if I want to predict displacement results, I can select displacement, click on predict, and we do get our displacement prediction. And we can, as I mentioned, we can move the sliders around. So this being a linear static simulation, the contour doesn't change too significantly. But if you do check the legend here for the contour plot, as I move the sliders, you can see max displacement of 15. Move some of these around, and we'll see that's now 12 or 13. So we are predicting the entire field there virtually in real time. You can, as I mentioned, train additional response types. So we will we'll select stress maybe, and we'll right click and select train. And this can take a few seconds, to maybe a minute, depending on the size of the model. This one is a fairly small model, so you can see it did get trained in just a matter of a couple of seconds. We can click on predict with that selected, and now we get predicted stress results. And same thing applies. We'll start moving the sliders around. Again, the contour doesn't change too interestingly in this example, but we can see just about 360 there. We'll move some of these around there, 395 by reducing this thickness, and so on. So you can really interrogate your model in real time now for any number of response types. So again, I think that's really exciting. Hope you do as well. And I think with that, let me jump back to here. And I think that's all. So thank you very much. Appreciate everyone's time, and hope you enjoyed both my and Atul's presentations this morning. Thank you.